Yes, folks, we are now doing lesson 4, still on vectors form 2. Today, I want us to learn how to extract movements in the Cartesian plane. So if I tell you from town A to town B, how do you get the movements? So vector addition with respect to Cartesian plane. Cartesian plane, you can easily get movements because of boxes. We shall be counting boxes. But remember, any point on Cartesian plane is determined by x coordinate and y coordinate, okay? Where x coordinate means either left or right, and y coordinate means up or down, okay? So let us look at this. I want to move from S to E, from S to E. So the previous lesson we learned that you have two vectors, okay? I have vector A that can be read as Sj, and then I connected to vector B that can be read as Je, Je. Okay? Those are the two vectors I have here. This is A and this is B. This vector Sj, you can see I choose to move from S to J. The movement I'm given to choose are here. X-wise and then Y-wise. What does that mean? When you are at S, you intend to go to J. Will you go on the left? Definitely no. You will move to the right. Then you ask yourself, by how many steps? It's just one step. I move here, one step. Then when you are here, you ask yourself, will you go up or down? The answer is up. You can't go down. When will you reach J? So right one step, and you know right is positive, and then up. How many steps? 1, 2, 3. So we write it right, up. You choose one, and we write it up, down. We write it in a column form. That is the language, that is the norm in vectors. So we write it up, down. Okay? Then, now I want to move from J to E. Again, you ask yourself, JE is a movement. What are the rules? 1, choose between moving left or right. So when I'm at J, I can't go left. I go to the right. How many steps? 1, 2, 3. You are already at E. For sure, you can't choose up or down. So I have chosen nothing. 0 means nothing. You have chosen no movement. Okay? So we can add these two. Add the top separately and the bottom one separately. So you have 1 plus 3 gives me 4. And then 3 plus 0 gives me 3. What does this result mean? This is a movement that takes you from the starting point to the end point. So let us confirm. I'm here. How many steps? 4. So I get 1, 2, 3, 4. I've already done the x-wise movement. Now I need to do y-wise. Now you ask yourself, the option is always up or down. Definitely, to go to E, I can't go down. So I go up. 1, 2, 3. That is the meaning. Okay. We can try another one here. So what we have done, folks, what we have done is we are trying to connect our movements. Okay. What I've done is Sj plus Je, and they get Se. Now I want to do another example. Suppose I have this. Let us call it C. Okay? That is vector C. I want to add it to this. And let me call it, this is vector D. So I have C and D. Okay? C and D. C and D. This is vector C, this is vector D. Let us give it letters. Maybe P, Q, R. So what am I doing? I'm doing PQ, you add to QR. That's what we are doing. So in a sense, I'm doing C plus D. We are adding. But we are trying to get the understanding of Cartesian plane. Like now, PQ. How is that movement written with respect to Cartesian plane? So what do? I write my bracket. The first thing that comes, I choose between left and right. So I'm at P, and I'm supposed to go to Q. Will you go to the right? No. I'll go to the left. By how many steps? 1, 2, 3, 4. So, left, 4 steps. You know, left is opposite of right. So if right, I'm taking it to be positive, and rightly so, we take right to be positive. You remember number line? Going to the right is positive. Cartesian plane, Going to the left, negative. Going up, positive. Going down, negative. So if I'm at P and I'm going to Q, I can't choose to go to right. I'll choose go to left. So left is negative. 1, 2, 3, 4 by 4 steps. I've reached here. I've already reached at Q. So you can't tell me I choose between up and down. I'm already at Q. So I cannot go up, I cannot go down. Why? I've already reached point Q. Now we go to D. I'm at D. I'm at Q. I want to go to R. So when you are at Q, you put the bracket. You want to go to R, You want to go to R. So will you go left or right? I'm at Q and my intention is go to point R. You are here. So I cannot go to the right. No. I'll have to go to the left. 1 step. So left, 1 step. When I've reached here, how do I go to R? You have option up or down. I can't go up because R is down. So I go down. How many steps? 1, 2. So I have gone down by 2 steps. So what is the final result? -4 and -1 is -5. 0 and -2 is -2. So this is P to So let us see. If you are at P and you want to go directly to R, which movement will you make? So if I'm at P and I want to go to this R, I have to move left 5 steps. So I'm here, left. 1, 2, 3, 4, 5. After this stopover, you go down by 2 steps. 1, 2. So this represents movement from P directly to R. This side show me 2 vectors the way they are added. Okay? I can do one more here. We can do one more. Let us have this here to that point, and then there. So let us have, this is L, M, and this is N. Okay? We have that. And what do we do? Let us draw the vectors. Suppose I have the whole of this, and then the whole of that. So let us have, this is maybe vector S, and this is vector T. So I want us to focus now. Here, I have some space where I can write. So from here to there, that is what we call vector S. And from here to here, we call it vector T. So essentially, what am I doing? I'm doing S plus T. I'm doing S, this is S. Remember previous lesson? Where the vector ends, another one connects without any contradiction of arrows. So you see, this is in harmony with that. So this, the first one is S, and we are trying to add it to T. So what do? There is space. I'm doing the way vectors should be written. Okay? You can watch up to that point. So you can focus a bit down. Yeah, there's enough space. Yeah, there is enough space here. You can see everything here. So this is S and this is T. So this movement LN is represented by S, and we are adding movement NM. So you can see I'm still connecting from the first lesson that the 2 capital letters represent movement. The first letter is where you are, the second is where you are going. Okay? Then what do we need to know when we are adding? When a vector ends, another one joins. You can see this arrow, they are in harmony. It is like a signpost. Go that way, and then when you reach here, you see another signpost directing you that. That is how we add. So I'm using 2 letters which show you definitely the direction. When you're using a small letter, it is accompanied with the direction. So you must connect right from lesson 1, lesson 2, lesson 3. This is lesson 4. Lesson 4 aims at you detecting. You are able to extract movement, like movement from L to N. You draw a bracket. In this bracket, we choose left or right. So when I'm at L and I want to go to N, the first choice I'm given is left or right. Now you can see definitely I have to move to the right. Right is positive. Then by how many steps? 1, 2, 3, 4, 5, 6, 7. So those are 7 steps. Now I'm here. If I reach this point, the next question you ask yourself, will you go up or down? I can't go down because n is up. So I go up by 1 step. I'm already here. So this movement 7, 1 written in column form represent L, N or just vector S. Now if you are at N, you want to go to M. You are here. This is the bracket for vector T. This vector T requires choice between left, right first. So if I'm here, surely I can't go to the right. I have to go to the left. Now left is minus, then steps 1, 2, 3, 4. So 4 steps to the left, you are here. So from here you have done 1, 2, 3, 4. So you are here. When you are here, you ask yourself, will you go up or down? Sure, I can't go down. I'll go up. How many steps? 1, 2, and you are done. Okay. So from L to M, if I wanted just to make a shortcut from L to M, what is that shortcut? That is what you are getting. So 7 add negative 4 is 3. 1 add 2 is 3. So let us see if it is true. L to M. Okay, L to M. 1 L. 1, 2, 3. This one. Then up. This is up because it is positive. 1, 2, 3. So we are very correct. What I need you to do is to get a Cartesian plane. Don't write anything on Cartesian plane. What I mean is this. Don't write here 1, 2, 1, 2, negative 1, negative 2, negative 1, negative 2. Don't label the axis. No. Just get a Cartesian plane. Then draw 2 vectors. Show the arrowhead. Okay? Show the arrowhead and see if you can get the objective. Our objective was to extract movement in Cartesian plane. A movement like this, QR, is negative 1, negative 2. That is the purpose. Okay? So once you know how to extract movement for vectors, then see if you can add them. When you add them, what is that sum for? What does it represent? It represents movement from starting to the end point. So you will be achieving 2 things. How to extract movement from Cartesian plane and adding them. What result does it represent? The final result you get represent movement from starting point to the end point. Folks, do that. You will have known everything in vector addition. Remember, vectors are written in column form. Okay? When you move from origin to a point, that is known as position vector. Anytime you start from origin to a given point, like we had point A in bracket 4, 3. If I want to write it in a vector form, so that is a point now written in vector form. So it becomes OA is equal to, then you put bracket 4 up, below it 3. That is known as position vector. Try to get the objective of every lesson. Extract movement. Movement are basically vectors. Now you are connecting life situation into mathematics aspect of Cartesian plane. Continue to subscribe. You will understand when I come back. Subscribe, give a friend, give another friend. All of you, you will sit for the same exam. Usiwe mchoyo. Stay safe.